All right. Some of this is review. You should know some of this from our last unit and maybe from grade 9 and 10. Yeah, this is page 93. Are you familiar with the terms atom, molecule, ion, and formula unit? Yes? Okay. Now, what we're going to do is for each one of these, we're going to write down what the overall charge is. The overall charge. What is the overall charge for an atom? Neutral. Because the number of protons equals the number of electrons. So the number of positives equals the number of negatives. That's going to come in handy in unit 3. What is the overall charge of a molecule? Here's our molecule.
Negative.
If it was negative, you would see this. Whoa. If you do not see a negative sign, that means that it is neutral, unless it has a positive sign. So if you don't see a positive sign, you don't see a negative sign, it is neutral. And that's because in a molecule, does anyone give electrons away? No. Does anyone take electrons? No. So all the atoms still have the same number of electrons that they originally did. What do they do with their electrons? They don't give electrons and take electrons. What do these guys do? They share electrons. That is a pair of shared electrons. And what do we call a pair of shared electrons? You guys know what that's called? It's called a bond. What kind of bond is it called? A which bond? Covalent. Yes, that is a covalent bond. And what types of elements are involved in a covalent bond? Sorry? Nonmetals only. Yep. Okay, so we have atoms. Their overall charge is neutral. We have molecules, which is nonmetals only. They're attached by covalent bonds, which are pairs of shared electrons. And they are neutral because no one has given away any of their negative charge, given away electrons. No one has taken electrons.
W2Z for their immunizations in the multipurpose room. Again, grade 9, W to Z to the multipurpose room. Thank you.
What is the overall charge of an ion? Positive or negative? If something is positive, has it gained electrons or lost electrons? It has lost electrons. If something is negative, it has gained electrons. And if it is positive, what is the name that we give it? That is a cation. And if it is negative, what is the name that we give it? Anion. And if we're not considering polyatomic ions, which we will do in a minute, but if we're not considering them right now, what type of element forms cations? What type of metal? Oh, I just said. Metals form cations. Metal ions, and anions are non-metal ions. Here we have an ion made of a single atom. Do you guys know what the prefix is that means one? Mono. This is a monatomic ion. It's made of one atom. So one atom. Here we have an ion that is made of more than one atom. Do you guys know the prefix that means many? Poly. Poly is many. So here we have a polyatomic ion. And do you remember what a formula unit is? I think we've talked about it, but I don't know if we stressed it very much. Well, first of all, what is the overall charge of this formula unit? Overall charge is, I've got Na plus, I've got Cl minus. What is the overall charge? Neutral. I know this is in the column for overall charge, but I'm going to put it down anyway. Neutral. The positive always cancels out the negative. And a formula unit is a single unit of what type of compound? Ionic. Gosh, it's made of ions. It is an ionic compound. Shocking, right? If you put many formula units together, what do you get? A crystal lattice. We get an ionic crystal lattice. Are these words all starting to sound quite familiar at this point? Good. Because you want to, when we're going into the next units, we want to just be able to say cation, anion, polyatomic ion, blah, 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 and you just need to like know what they are, like, and not have Ms. Spence just up here rambling about stuff. Okay, do you know where the metals are on the periodic table and where the non-metals are? Like if you were to look up at that chart over there on the wall next to the clock and the Muppets, what color are the metals?
Blue.
Blue. What color are the non-metals?
Pink.
Pink. And what are those purple things?
Metalloids.
Metalloids. All right. So for now, we're not going to worry about metalloids. We're just going to say we've got metals and non-metals. All right. That's just to make our lives easier. So everything to the right of the staircase is a non-metal. Except who? Who is weird? Who is out of place, sort of, but not really? Hydrogen. Non-metal. And then all the rest are metals. Okay, everything, including those guys at the bottom. What state are most metals?
Solid.
Metals are mostly solid. Who is the exception? Exception, mercury. Yes, mercury is a liquid. Why did I put brackets there? There's no brackets. There doesn't need to be a bracket. Okay. Now, nonmetals. Do you know what states nonmetals are? Gas? Is carbon a gas? What's in your pencil? Lead. What's the lead made of? Is it really made of lead? Would we let children go use lead pencils? No, we would not, because lead is very toxic. What is it actually in your pencil?
Carbon.
Carbon. It's graphite. Okay, it's a form of carbon. Do you guys know what diamonds are made of?
Carbon.
Carbon. So is carbon a gas? No. So carbon is not a gas. Silicon is not a gas. Phosphorus is not a gas. Sulfur is not a gas. So there's a lot of nonmetals that are not gases. So we have some gases. Obviously, the noble gases are gases. Okay, fluorine, chlorine are gases. However, bromine is, where's my little thing here? Bromine is a liquid. Mercury is a liquid. They're the only two liquids at room temperature on our periodic table. Do you guys remember bromine? Bromine comes in what form? Br. Oh, that's bromide. Bromide is Br minus. Bromine is neutral. And what format does it come in? Do you remember? It's Br2. Do you remember all your diatomic elements? See if you can tell your partner, what are all your diatomic elements? You can say iodine or iodine. Yeah.
All the way down to iodine.
Now, if you have forgotten, nitrogen is element number 7. Yes? We can then draw a 7. Do we like that 7? Let's see if I can fill it in with some highlighting here. Okay. There's our 7. All of those are diatomic. There is one more that is diatomic. Where is it? Hydrogen, because we have the hockey stick. Do you guys see that the 7 is kind of like a hockey stick? Yes. And we have the, what is hydrogen? Hydrogen is the puck. Okay. Hockey stick and puck. The hockey stick plus the puck is the diatomic elements. And if you can't remember the hockey stick and puck, let's say maybe you're not a sports fan, maybe you just need to ask Dr. Brinkelhoff. Okay? Also the diatomic elements. Or maybe you just need to have no fear of ice, cold beer. Okay, so I don't care which way you remember it, just remember them. I know we've done this before, but you need them to be in your brain because when we write reactions, you need to know that if bromine is on its own, it is Br2. You need to know that carbon on its own is not C2 because it's not one of the diatomics. Okay, so you need to know which ones are and which ones aren't. It's only when they're on their own though. NaCl, is it NaCl2? Anyone ever heard of NaCl2? No. So if they're in a compound, they're not diatomic, only when they're on their own. All right. So our metals are mostly solid, and in fact, they form, can you guess what we call this solid crystal structure? It is a metallic crystal lattice, yes. So this is a metallic crystal lattice. Exception, mercury, because mercury is a liquid at room temperature. So these are solids. How can you tell that this is a liquid and not a solid? Chat with your partner about that. How can you tell that this diagram here is a liquid and not a solid? What do you think? It's a liquid, not a solid, because it's all bleh. I know that's not a great definition, but I'm not going to have you write a definition of a liquid. I'm just going to have you recognize a liquid. So what are liquids like? Liquids are like bleh. What are solids like? Liquid, bleh. Solid, liquid. Everyone, solid, liquid, solid, liquid. Okay? Are you ever going to forget that? And I can't even do gas because what I would have to do if I wanted to do a gas, I would have to rip off each individual finger and fling it to opposite sides of the room, and that would be really, really disturbing. So we're not going to do that because solids are all stuck together. Liquids are all stuck together, but they're able to flow past one another. Gases are completely separate from one another, okay? So what do we have over here? What state of matter is this? That is a gas. Is it one of our diatomic gases? No, so I would like you to look at the elements and tell me what type of gas that would be. It would be a noble gas, okay? This is a monatomic gas. Therefore, it is a noble gas. We good? Cool. All right. Molecules, remember we said they are neutral. Remember we said they're made of only nonmetals. Molecules are made of 2 or more atoms. If you have only 1 atom, what do you have? Oh, we missed that. Molecules are made of 2 or more atoms stuck together by covalent bonds. What do we have if we only have 1 atom instead of 2 or more? It's like almost a trick question. If you only have 1 atom, you have an atom. Okay, there we go. All right. Molecules are bonded covalently. What does it mean to be bonded covalently? They share electrons. Yes. Can a molecule be an element?
Yes.
Yes. If you have iodine bonded to iodine, that is 1 element. So that is a molecule of an element. If you have 4 phosphorus all bonded together, that is 1 element because all the atoms are the same. If we have sulfur, that is 1 element. Okay? Now, these particular structures here, if you draw your structures this way, there are balls. Look at that, see? Ball, 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 ball. And they are attached together by sticks. So we call these ball and stick models. Okay? These are all ball and stick models. Alrighty? So you can have molecules that are elements where all the atoms are the same. Or you can have a molecule of a compound where you have 2 or more different types of elements. We've got hydrogen and oxygen here. We have hydrogen and carbon. This one has nitrogen and oxygen and hydrogen and all kinds of things. Yes? Do you remember what we call these tiny little numbers down at the bottom? Those are called subscripts. What do they tell you? Take a look at the picture, CH4. What does that little 4 tell you? That there are 4 hydrogens. It tells you the number of an element, number of atoms of an element. And we need to make one little correction here. It should be C8H10O2N4, because if you notice, we have 4 blue molecules, not just 2. Okay. Molecules can be represented by the ball and stick model shown above, or do you see the difference here? We have sulfur and sulfur. This is more accurate, but harder to figure out who's in the molecule, yes? And we call those space-filling models, okay? Okay. We can do one more page. We can do one more page. Yes, we can. I wonder if we can do 2 more pages. Let's try it. Ions. You know that ions have an electrical charge. They are either positive or they are negative. Monatomic ions have 1 atom. Polyatomic ions have 2 or more atoms. Cations are positive, anions are negative. Cations are formed from metal atoms. Anions are formed from nonmetals. There are both polyatomic cations and anions. Here's just like a little memory thing. Cats have paws, so cations are positive. A negative ion, or onions make you cry, which is negative. You can show the charge either inside or outside of the picture. Inside or outside of the picture. For polyatomic ions, very often what we will do is we will put brackets around it and we'll put the charge on the outside. You're not going to have to draw this, but you will need to recognize it. You'll look at it and go, many atoms, charge, polyatomic, ion, many atoms, polyatomic, has a charge, ion. Yes? Now, sometimes we don't put the brackets, and that's okay too. As long as you have many atoms with a charge, that is a polyatomic ion. Formula units. Remember, what charge are formula units? They are neutral. And what you're going to have is you're going to have a positive together with a negative. Or you might have a 2 positive with a negative and a negative. Okay? An ionic crystal lattice. You'll notice that it's really organized. A 2D slice looks like that. A single unit looks like that. Now, how do I know that this one here is probably an ionic crystal lattice? Rather than a mixture. How can I tell? Tell your partner. How can you tell that that's probably ionic crystal lattice rather than a mixture? It has a very regular pattern. Plus, minus, plus, minus, plus, or whoops, minus, plus, minus, plus. Plus, minus, plus, minus. See, it's alternating. We have an alternating pattern. All right, lovelies. So you guys are going to do pages 97 to 101. And
this is a reminder for Brad, if you've ordered Bradware, it is available for pickup at the office at lunch. And for staff, there are leftovers from last night.
oh my God, shut up. I just want to give them their homework. All right, so we have pages 86, 87. Yes? Now, in addition to that, if you had a really hard time with that dimensional analysis quiz, what should you be doing? You should be doing Hebden, page 14 to 16, numbers 2 to 10 if you want to redo the unit conversion quiz, not the one from today, but the one from 2 days ago. I'll put all of this on Teams so it won't be so disorganized, okay? This is gonna be next Thursday.
Seems like there's no way like teams just any guys that sit there and be. Okay.
Okay.
And then try.
Okay.
So
get back. That way you guys don't force you the workbook for the next minute. So in fact, let's give that to you right now, okay? Because some of this is gonna be assigned, it's gonna be like, one A, C. Thanks. Yeah, at least here, probably actually, yeah, at least that, I'll let you know, I'll pay for it. Okay, this is all reviewed from last year, and so is some of this. So, I just have to remember what page I assigned, because I don't want to do too much of it. That I'll have to get that to you on Monday. Okay, yeah. Hi. I have not had an opportunity. We had all those parent teacher things last
I
night.
might
so-
have done worse on that one.
Oh, okay.
So just
Oh,
saying.
dear,
So I might
okay.
redo it again.
Yeah, yeah. Would you like it back by after school today, or are you good?
I'll just come in Monday morning.
Okay, that's
Yeah.
perfect. Yeah, sounds good. Hi.
Be available at all. I'm wondering like this presentation conferences, but like, is it possible for me to write the one? Oh, really?
We just get early dismissal because we had to work until 7 last night.
Oh, okay.
So we worked until 7, so they give us an hour off today in
They
compensation.
really should give more.
Right? Right? We're all like, what? Anyways, it's all good. Yes, you can absolutely put that after
It'd be
school.
the one that I just did because I know I messed something up.
Sure thing. Yeah, no problem. Thursday. Next Thursday. Yeah. Hi, Minnie. Let's grab this one. Mini time. Here we go. There you are.